Hello everyone, my name is Akash Patel and welcome to my second video of Computer Network 11 guided by our respected professor Dr. Govindaswamy. So in the first video, we talk about the basic of networking, what network are, how they work, and why they matter. In this video, we will go one step deeper. We will explore something called network architecture, which simply means how a network is designed, connected, and organized. We will talk about the network edge, the network core, and access networks, which together make up the entire structure of the internet. By the end of this video, you will understand exactly how your phone or laptop connect to websites and servers all over the world. Let's begin our journey. So, what network architecture? Network architecture means the design or blueprint of a network, how computer and routers, switches, and servers are arranged and connected to transfer data smoothly. So this think of it like a city plan. That roads are the cables, routers are the traffic lights, and data packets are the vehicles moving between homes and offices. So it defines how data moves between the senders like your phone and the receivers like a website. It also ensures that communication is fast, reliable, and organized. Just like city traffic rules make sure cars move safely and efficiently. So the internet structure has three main parts: the edge, the core, and access networks. We will explore all three one by one. So let's see first purpose of architecture, network architecture. So why do we even need a network architecture? Well, imagine if every computer tried to connect to every other computer directly, it would be chaos. Architecture provides a systematic structure that makes your device can communicate efficiently without confusion. It also helps keep data secure, organized, and fast, even when millions of users are online at once. For example, when thousands of people watch Netflix at the same time, the internet doesn't crash. That's because the architecture distributes and manage all the data smartly. In short, network architecture is what keeps the digital world running smoothly 24 by 7. So let's move to the next slides, the network edge introduction. So the network edge is the point where devices like laptops, phones, and computers connect to the internet. So this is where users, people like us, send and receive information. You can think of the edge as the starting and ending point of data communication. For example, when you open a YouTube, your phone or computer is at the edge because that's where the request starts. The YouTube servers which stores videos. This also an edge device on the other side. So both sender and receiver side at the edges of the network. Let's move to the next one. And you can see the diagram of client and server at edge. Device at the network edge. Let's see. The edge includes many kind of devices. Client device like a phone, tablets, or laptops. These are the ones we use. Servers, which are big computers that stores websites, apps, or data. Edge routers, which connect local networks like your Wi-Fi to the larger network internet. Let's talk about real life example. When you stream a Netflix movie, your smart TV is the client device sending a request, and Netflix server is a data center, is the edge device responding with the video. So in short, the edge is where user meet the internet. Let's see some client server model. So most communication at the edge follow something called the client-server models. Here's how it works. The client, that's your device, sends a request for information. The server, that's the provider's computer, receive the request and send back to the data. For example, when you search weather today on Google, your browser acts as a client and send a request to Google servers. The Google servers process that request and send back to the weather results, and you see them in second. So this request and response pattern happens billions of times every second across the internet. So let's see peer-to-peer model. So there is another model called peer-to-peer or P2P. This is in this type every device is equal. There is no dedicated server. Each device can send and receive data directly. For example, file sharing application like BitTorrent use P2P, where users shares file directly with one another instead of downloading them from a single server. Another example is Bluetooth file sharing. When you send photos from your phone to another phone, both devices act as peers. P2P is fast for small groups and doesn't rely on big data centers. So let's see access network introduction. So next we have access networks. These are the networks that connect users like you and me to internet through an ISP, Internet Service Provider. Access networks are what make it possible for you to go online at home, school, and or on your phone. There are three main types. First one, home networks. Second one, enterprise networks, and third one, mobile networks. You can see here in the diagram. Then let's talk about the next, home access network. So a home access network is what you use every day. Your router connects all your personal devices, laptops, phones, smart TVs, and printers to the internet. The router gets internet access from your ISP through a cable or fiber line, and it uses Wi-Fi to connect your device wirelessly. For example, when you open Netflix on your smart TV, the data comes from your ISP through the router to your TV. Every day you do at home, online happens through your home access network. You can see here your simple home network. Then let's see the enterprise access network. So enterprise networks are large network used by companies, schools, and organizations. They connected hundreds or even thousands of computers together so employees can share data and resources securely. These networks are multiple switches and routers along with firewalls and VPNs for protections. For example, your college campus networks, all the labs, computers, printers, and servers connected there an enterprise access network. It allows file sharing, printing, and communicating inside the organization. So let's see the mobile access network. So mobile network connect your phone to the internet without Wi-Fi. It uses cell tower instead. When you use 4G, 5G, or LTE, your phone connects to the nearest tower, which passes your data to the mobile provider and then to the internet. For example, when you scroll Instagram using mobile data, your phone sends and receives information through a mobile access network. That's why you can use the internet even while traveling in the car or bus. So you can see here in the diagram. Let's see the network core introduction. Now we come to the heart of the internet, the network core. So the core is like the internet's highway system. It connects all the smaller access network together using very high speed routers and fiber optic cables. If the edge is where communication starts and the access is your local road. Then the core is the super fast highway that carries data across cities and countries. It made up of powerful routers and large data centers that keep the internet connected globally. You can see here. Then let's talk about functions of network core. So the core has three main functions. First one, high-speed transmission. It moves massive amount of data across the world. Second one, routing. It decides the best and fastest path for data packets to travel. Reliability, it keeps data moving even if one path or router fails. For example, if you are in the US watching a YouTube video host on a server in Japan, your video data travel across overseas cables and routers through the network core all in milliseconds. So that's how the internet stay fast and stable. So let's see circuit switching versus packet switching. There are two-way data can travel through the internet. First one, circuit switching, a dedicated connection between sender and receiver, it like a private phone call. This was used in old telephone system. Second one is packet switching. Data is broken into packets and each packet travels through different routes independently. It's like sending the letter that take different roads but all reach the same destination. Today, the internet uses packet switching because it's faster, more flexible, and user resource efficiently. You can see here in the picture there is a packet and there is a switches. So let's move to the next one. So you can let's talk about how edge, access, and core work together. So let's see how everything connects. First, you, the user, are at the edge, your laptop or phone. You connect to your Wi-Fi or mobile data, that's your access network. Third one, your data travels through the core network ac- across routers and cables until it reaches the destination servers. The response travel back the same way. Uh, when you open YouTube, your phone means edge, Wi-Fi router means access, internet backbone, core, and YouTube server edge again. You can see here how it can be passed. Let's see the examples by visiting a website. Let's follow a real example step by step. You open your browser and type www.amazon.com. Your computer ad sends a request through your home Wi-Fi means access. The request travels through routers in the internet core to reach Amazon server. The server process your request and send the page data back. Your browser display the Amazon homepage instantly. All this happen in less than a second thanks to the power of internet architecture. Let's see some summary of network architecture. Let's quickly review what we learned in this video. We learned that network architecture is the structure that connects the world. We explored the internet edge, network edge, where device like client and server communication. We learn about access networks, home, enterprise, and mobile that connect user to the internet. We explored the network cores, which is backbone of global communication, and we learned how packet switching help data move efficiently across these layers. So that's it. Thank you so much for watching my second video of computer networking. It's a network architecture for computer networks. I hope you understood every small concept clearly, from how the network is designed to how your phone connects to the server across the world. A huge thank you to my Dr. Govindaswamy, my professor, his continuous guidance and supports. If this video helped you understand better, please don't forget to like, share, and subscribe. It's really motivate me to make video more educational videos like this. So this is Akash Patel signing off. See you in video 3, where we will continue exploring more advanced network concepts. Thank you again, and keep learning because knowledge is the best connection you can ever build.